Hi, if you're watching this video, you're watching my video on water systems. In this video, we'll be talking about ice, glaciers, and the importance of frozen water on the planet. So, as we mentioned in previous lessons, most of the world's fresh water is frozen, 70% of it, in fact. So, this can be in the form of icebergs as well as glaciers. We'll be focusing in this unit about glaciers because they are larger and they're more predominant in Canada. Glaciers are large collections of unmelted snow and ice that flows across land. So you may not be thinking of ice and ice fixtures as flowing on land, but if you were to watch a time lapse of a glacier, you will actually see chunks of ice moving over time as the snow and ice melts and refreezes, pushing ice down the valley or down wherever that glacier is located. So glaciers are a large collection of unmelted snowfall that flow across land. How do glaciers form? So basically, as snow falls, it starts to build up layers. And as you add more layers of snow, more pressure builds up onto the bottom layers. And so those snowflakes tend to get compressed further and further until they form something called glacier ice. So these snowflakes, as you add more layers, the bottom layer gets compressed so much that it becomes very dense and very thick ice. As snow falls and builds over time, more pressure is added to the bottom layer. This pressure builds and pushes the snow together to form ice. This video will talk about that process and how it works. I'm not going to play in this video. You can watch it in the notes on D2L. Types of glaciers. There are two main types of glaciers. There are valley glaciers and continental glaciers. Valley glaciers are typically found in valleys, right? And it's found between two high mountains because as snow falls, the snow can roll and collect in the valley. And so you can add more and more layers of snow, creating that pressure, right? And creating more of that glacier ice. So typically you will find valleys with glaciers near mountains. An example of this would be Jasper. You can see this glacier if you were to drive up to Jasper, and you'd see this massive flow of ice in between two rocky outcrops. Continental glaciers. These are glaciers that are so massive that the ice can be even taller than mountains. And this is just a constant buildup of snow and ice over centuries that creates these massive glaciers. An example would be Antarctica, right? When you look at Antarctica, you're not actually looking at the land. You're actually just looking at a huge amount of ice that is built up over centuries. Glacial movement. So we mentioned before that glaciers flow. Well, as snow builds up on glaciers, it makes the glacier flow outward. This massive movement of ice can have massive impacts on the ground as it moves across the surface. So here we see the glacier. And so as precipitation or snow is added to it, right, it starts to squeeze the snow and ice here. Well, as it's being squeezed, it's pushing outwards, right? Which is then pushing outwards, all the way to the edge where this ice is pushed out and flowing outwards. What ends up happening is some of that ice and snow will melt, right? And as per the water system, come back up, snow back down, and add to the pressure on the back end, causing that ice to push out again. And so this cycle of melting, freezing, precipitation will cause the glaciers to move. In addition, as the glacier is being pushed forward, it's also moving against the ground, which can cause striations or patterns on the rocks below. So when glaciers move, they can pick up rocks and sediment. And as these rocks are being pushed across the ground, the rocks scratch the surface of the ground, creating these things called striations. Striations just mean stripes, so you can see that these are scratchy stripes across the surface. This is a form of erosion. So you may remember from grade 4 and 5 when you talked about how water can break down rocks. Well, glaciers break down rocks by picking up other rocks and causing them to rub against each other, causing them to scratch off each other. creating these striations. In addition, if the glaciers start to slow down, right, if the flow is slowed down because of higher temperatures or whatever's causing the glacier to slow down, like lower precipitation, what can happen is a lot of the rocks and dirt picked up by the glacier is left behind. Rocks left behind by a glacier is called till. So these are called striations, right, these lines, and the leftover sediment or rocks by a glacier is called till. And it just kind of looks like a dirt wall with a bunch of rocks, large rocks, in the middle of it, because they have been left behind by a receding or a glacier that is reduced in flow. When a glacier melts faster than the snow falls, the glacier will pull back, right? So as this glacier is sort of like shoveling all this dirt up, if it were to start to recede or move back, then this pile is left behind. So as the melting is moving faster than the glacier is pushing forward, the glacier will then melt backwards. And this will create something called a moraine. And it's basically a hill of dirt and rocks pushed out by the glacier. As glaciers recede, meltwater flows out. This is called outwash, right? Because it melts out and washes out. So this glacier here is receding, and the water is flowing out. So this is called outwash. And this is very important because the outwash is what feeds all the rivers in Alberta. So all the rivers, all the sources of fresh water come from glaciers in Alberta. And they come from outwash, melting glacier water. And so as these glaciers melt, the water flows out, enters other streams and rivers, and eventually reaches the Bow River or a reservoir. And that's our source of fresh water. So that's why it's important to know this, because all our fresh water, especially in Alberta, come from glaciers. And it comes from their outwash. So about 11,000 years ago, that's when the Ice Age ended, and most of Canada was covered in a massive continental glacier, right? This shaped the surface of Canada. So as mentioned before, as glaciers move, they can pick up rocks, and those rocks can scratch the surface of the ground. In addition, they can leave piles of dirt called till or moraines, and that can change the surface of what Canada looked like. So without this glacier, Canada would look very, very different. So all that ice affected the climate. So during ice ages, if you had a massive glacier, what happens is the sun will hit the glacier, but because glaciers and ice are white and bright, they reflect all that light. So what that means is if the light is not being absorbed, if the light is not going into the ice or into the ground, it's not being converted into heat. And so what happens is glaciers keep things cool by preventing light from being absorbed. Right? Typically, light will hit the ground, and that ground will absorb the light. And that light absorption will cause heat. But during ice ages, glaciers will reflect that light and slow that heat from being built up because that light is being reflected off. Ice and snow reflect light and prevent it from hitting the ground. If it did, the light would have been converted into heat. So glaciers today, they're shrinking faster than ever. Well, this is due to global warming from greenhouse gases, right? So these gases sit in our atmosphere, and what happens is when heat hits our planet, usually it'll hit our planet and some of it will go off, some of it will get absorbed. But because of more greenhouse gases, that heat gets trapped and then reflected back into the ground. It gets absorbed, goes back up. The greenhouse gases catch it and throw it back down. It's like dribbling a ball of heat. And so as we get more greenhouse gases, that heat is being reflected into the earth more and more and being absorbed more and more. And so that's how greenhouse gases affect global warming, right? So this trapped heat melts the ice. So as more heat is being trapped, it melts the ice. The less ice, the less energy is reflected from the sun. Because again, The glaciers reflect that light, so it prevents heat from building up. But as they melt, more heat is building up, less snow to reflect the light, which causes more heat to build up. And so it creates this feedback effect of more heat, more melt, which causes more heat, which causes more melting, which causes more heat, which then causes more melting. So this is basically talking about the importance of glaciers, their importance to our environment, the importance to our climate, and importance to our sources of fresh water. Hopefully you found this useful, and I'll see you next lesson.